The general theory of relativity first came out in 1915 and transformed our view of the cosmos. It has consistently been called the most beautiful theory of physics ever invented, and is currently our best theory of gravity. Among other things, it predicts the existence of black holes and singularities, which I will go through in the next video, so keep a lookout. But all of it's not flowers and Danish people, it also has some fundamental problems. The most important flaw being that it does not seem to be compatible with quantum mechanics at all. Einstein started to develop the theory after he had his happiest thought in 1910. This came from an experiment he conducted in his own mind, a thought experiment. So let's do it. Imagine you're standing in an elevator in space. There are no windows and no light, you can only feel what's happening in the box. Suddenly, it feels like you're pulled down by a force. But here comes what makes Einstein Einstein. He understood that there could be no experiment that decides if the elevator is accelerating upwards and is pushing your feet, or you're being pulled down by gravity. This idea that laid the groundwork for the theory that made Einstein the person of the century, according to Time magazine. But what does it say? What does it mean? Let's find out. The special and general theory is not to be confused. This one, the general theory, concerns the force of gravity. Why the rabbit ears, you may ask? Well, the theory says that gravity isn't a force pulling objects, but rather a geometrical distortion of space-time, a curvature. But what is space-time and geometrical distortion? Let's do one at a time. If you haven't been living under a rock, the weight of the observable universe, you've heard of space. It's three-dimensional. You can move up, down, left, right, forwards, and backwards. You've also heard of time, what always makes you come late to parties. This is one-dimensional. It's only a straight line, forwards and backwards. But in our case, you can only move forward. Why? Mainly because of statistical mechanics and entropy, and that, ladies and gentlemen, is another video. Well, space-time is now just a merge between these two concepts into 4 dimensions. Our brains have evolved in 3 dimensions, and that makes it kind of hard to picture it. But you can try. I encourage you. And geometrical distortion, curvature. Well, this one's not as easy to explain, but I'm going to try. With the theory comes Einstein's field equation. It's divided into 16 parts and a lot more mathematically complicated than it might look on the first sight. And it looks complicated. The famous physicist John Wheeler put the essence of the theory as simply as it can get. Space-time tells matter how to move, and matter tells space-time how to curve. Picture it like this. You're standing on the equator in Colombia, snorting cocaine. And your friend Arman is standing on the equator in Congo-Kinshasa, fighting for his life. From your point of view, the ground is a 2-dimensional surface. That's also why some people think the Earth is flat. Your friend is quite far away, but both of you agree to move straight north. To see who gets there first. Let's see what happens. Wow. And remember, do not try this at home. The fact is, when they get there, they will be together. How come? Well, from the beginning, it looked like they were moving in opposite directions on a 2-dimensional surface. We can all agree that no force actively pulled them together like this. It was simply the geometry, or the curvature of the Earth in 3 dimensions that made their paths converge. Einstein says that gravity works in the same way, but in 4 dimensions. To summarize, why does it look like the Earth is pulling the ball down when I throw it up? Einstein would answer that I accelerated it in a direction of space-time. It traveled in a straight line, but we don't see a straight line. But remember, we mean straight line in 4 dimensions. And the mass of the Earth curves this line into the chord. There is also fun predictions from the theory, like gravitational waves, detected by LIGO in 2016. Gravitational lensing, which makes it possible to see the same astrophysical object in different locations at the same time. And also, let's not forget gravitational time dilation, which literally means that the center of the Earth, our molten core, is 2.5 years younger than the surface. The weaker the gravitational field, the faster time moves, and vice versa. Our modern GPS system builds upon this principle, and so does lots of the technology around you. Just imagine the world the physics is able to create with only ideas and mathematics. You can be a part of it all. Don't forget to like, hit the bell, and subscribe. Have a nice day.